Okay, good. So, good morning, because sometimes this technology can be challenging. So, good morning and good evening, and to everyone for making time to listen to a brief from Africa. And I'm also happy that what we started in Clemson is becoming a reality. And I am making plans that next year, hopefully, I will also visit you in person at your institute. So this is something I am working on. So I think there's already a lot said about me, so I'll not go much into that. But to just briefly mention a bit about the university where I'm a worker. So the University of Energy and Natural Resources Ghana is a very young one. It was established in 2011 because the government realized that it was very important because you see most of the world's natural resources come from Africa and also come from Latin America. So you can see the similarities between Latin America and Africa. In the case of your country and our country, that we have a lot of resources, but the ability for us to gain economically with these resources has been a challenge. And one of the challenge we have had is the human capacity. So our university is pushing hard to train the young ones to be able to know the cutting edge technologies that they can apply in order for us to be able to leapfrog our natural resources and our energy resources. So that is brief about our University of Energy and Natural Resources. And I am also hoping that in the near future too, some of you can also visit our university and to also see where we are. Thank you. Now, on the topic that I need to talk about today, I would like to give a brief background about Ghana. So this is Ghana, and this is the map of Ghana. So you can see, because you are quite, some of you are water people, you can see that Ghana is beautifully decorated with blue colors, which means with a lot of rivers and lakes, and we pride over this. But do take note that the lake, the this large water body you are seeing, which is called the Lake Volta, is not a natural lake. It is a man-made lake. I think that is something I want to emphasize. It is a man-made lake because of the dam, Akosobo Dam. I don't know if I'm able to use the screen stuff. I'm not good with it, but if you can see on the screen, but there is a dam called the Akosombo Dam. It's a hydroelectric dam, and the purpose of this dam was to generate in energy, hydroelectric energy for the country. And up to now, as we speak, hydropower is still our biggest share of our electricity generation. So you can see the importance of water use in Ghana. Now, aside that, of course, drinking water is critical. We need that. It's essential for us for our survival. But to also mention that there are other uses such as mining, because we have a lot of small scale mining, and mostly sometimes they also use the river bodies in going through the purification and what have you. So in terms of water use in Ghana, there's a lot of competition, and I'll be happy to know from your country how water use is also competitive on the different sectors. So on that note, I want to go through a number of what I call works which were done. Luckily, some of my team who were either PhD students or they were either what I call master students. They have also joined. So if there are some specific questions, jointly we can help to address them. Now, the first topic which we want to talk about is groundwater vulnerability. Why is this very important? This is very important because in our part of the world, access to clean water is still a challenge in most communities. Access to clean water is still a challenge in most communities. So, but in addition to that, there is also what we call access to sanitation. These two things are very critical for us. So that is why you will find in Africa that there is usually a coined term called WASH, water, sanitation, and hygiene. WASH programs are many in Africa because they are trying to see how they can support a lot of communities in getting clean access to water and clean access to sanitation. And because of the challenges we have with our infrastructure, from getting water from what I call from the government sources or from private companies, a lot of communities would prefer to rather drill a borehole, or a lot of individuals would prefer to drill their own borehole, which is the common practice. So you find that in most communities, their access to water is by drilling, drilling a borehole in trying to access some water in their groundwater basin. So this gives a sense of what I call a bit of pressure. And in this particular area, the Pra Basin, which the map is showing here, aside the fact that people are sanitation is a challenge in terms of the planning, and people are also drilling a lot of boreholes. The other challenge in this particular study area is also the fact that there's a lot of mining activity going on. So, as water experts, you can just imagine the possible contamination and pollution that can really hamper the usability of your groundwater. So that was one of the motivation for conducting this particular work. Now, for us to do that, we had to go to, so this is a typical borehole. You can see my student trying to take some samples from the borehole. So this is more like a standpipe. You have to add some energy to it for it to be able to pump the water from the ground. So we took some samples, and the purpose of taking these samples were to test for the water quality, and also importantly to look at the heavy metal concentration, because of the fact that there are a lot of mining communities in this area. So after doing that, um, we had another objective, which I want to stress on the objective 3, is that we wanted to be able to map our groundwater vulnerability by using a model that we ourselves have created, and it is called the F Hydra model. Now, this is a very simple model uh, which takes into account flow accumulation, land use, land cover map, and hydraulic conductivity map. And with this, we are able to analyze, and we are able to make some kind of a decision on how we should be able to plan our groundwater resources. It may looks like straightforward to, I don't know the case in your country, but in Africa and in Ghana, to get access to data is one of our biggest challenges. And that is why the integration of Earth observation becomes very critical for us. So these are some of the initial and some of the findings from this work. So we perform the laboratory works, which is the norm using the standard practices, and then we compare this to our Ghana standards, authority standards, to see whether some of the results were high or low. But upon going through, I think the key thing was that with the heavy metals, these were very high, and of course, that required us to more or less inform the people who are using these water sources that they need to advise themselves health-wise on what they needed to do. Then we now went on to also apply the F-Hydra model, which I have discussed. So first you have the digital elevation model, you have your flow direction map, which these are easily generated. Then you have your flow accumulation map, then you have your land cover map. Now, once you have this, you use the approach of the AHP, analytical hierarchical method, or method, you use that, and with that, you are able to, uh, so you have your hydraulic conductivity map. Then, based on our own experience of our Ghana system, then we are able to apply certain weights with reference to a popular model, which is called a drastic model, which we have done some comparison, and the results have always been very good. So with this, then we are able to generate our flow, our F Hydra vulnerability map. Now, it will be interesting for you to know that this map, looking simple like this, is very informative for our governments to take necessary actions in trying to know which areas are more vulnerable and which areas are needs some kind of attention. So this was the case for this particular study, and I will go and show another example of another study. So if you look at the results, so generally, after we compare the results from our work with other works, I think the results were scientifically okay. And we also compare the results of this work with the drastic model, which is a US-based model, which also shows that the performance were very good, which means that our local model, F-Hydra, has really performed very well. So this is something we continuously engage more students on to further review it and to further consider other aspects of whether we are going to add aspect of machine learning to it to improve its accuracy over time. Then, you see, I have presented a number of results, which is in table form, which are giving the different water quality parameters. Now, one other thing we are doing in our study team is to convert all these different parameters into what we call the water quality index. For us, this is very important because the water quality index gives us what I call a social communication tool to tell us whether, when you assess all the water quality parameters, whether the overall quality is bad or good, because that is the message that we are able to tell to our policymakers. So we also did some analysis, and from this water quality index, at least 60% was fairly good, which means that the other 40% needed some measures that needed to be done, especially the cases of the heavy metals. And this is also, we went further to further also calculate the health hazard quotient and hazard index, because these are all ways by which we can be able to talk about the fact that the use of groundwater is also associated with public health, and hence the need for different partners to come together in order for us to be able to address the issue. Then we went further. This was another work which was done by one of my PhD students, Dr. Gustav. Currently now he's the director for the Community Water and Sanitation Agency, which is very important because now he's sitting at the policy side. So I'm also going to give brief outcomes from this particular work. Now, the problem in this particular state area, which is the central region of Ghana, are the fact that a lot of people are dependent on groundwater. This is the first thing. So there is more people trying to depend on groundwater. But the challenge also is that when you drill, you either meet salty water, saline water, which is also something which is in our current economic situation, it is very expensive to treat. So there is an issue of how do we then develop a way by which people, community water and sanitation agency can understand where are the areas that you can drill and where are the areas you cannot drill, so that at least it will reduce the burden of drilling, which is very expensive, and finally you find no water at the end of the day, or you find the water and it is very salty. So this is the steady area. I must say, maybe when you have chance to visit Ghana, it will be, it's also a tourism area, because this is also the first, one of the first places in the part of our Ghana that when our Western colonizers, this was the first place of settlement, and this was also the route for slavery. So, and this is going to, this will be another topic. We are talking about groundwater here, but there is a lot of tourism here to look at how slavery has gone through in Africa in general. Now, when you look at this steady area, um, it's along the coast, so of course, close to the sea, so you have the issue of seawater intrusion, which is a common problem in this particular zone. So we apply the methodology of getting some rainfall, our geological and soil maps, also getting some pumping test parameters, and also adding some chemical data, then also applying the satellite data such as the DEM, then mixing this together, then we're able to produce what we call the groundwater potential map, which I said it is for us to use this to understand where are the potential zones and what are the possibilities, so that it makes it easier for both private and users and policymakers to know what exactly to do. Now, these are some of the results. So we derive all these different maps. Now, the good thing is that all of these results, most of these things I'm presenting here are also published. So it means that later, if you want detailed methodology on how all these were derived, you can be able to receive that from the links that I will share. Or if you just Google my name, it's possible to see all of these things. So the interest here is that we combine all these maps together with the water quality parameters that we assess. Then we are able to also have what we call the water quality index. And this is telling us that the areas that the water quality index is poor, it means we need to spend more time with all the necessary stakeholders in trying to see what we can do in trying to improve the water quality in this particular source. So these are other maps that we have also used in trying to reach to some of the things that I am coming to talk about. So we combine all those different maps using the AHP method, and at the end, then we are able to say that a certain proportion. So if you look at this map in general, the areas that have high groundwater potential is very small, but you also see that the areas that have very poor are also along the coast, which is one reason being that along the coast, first, the population density is very high, and two, you also have seawater intrusion. So these are some of the things that are causing some challenges, which also means that it can help us to know how to diversify our urban planning to ensure that at least we are not overstressing our groundwater resources. So there is a paper to this. So if you want more details, you could go through this paper and you could further get more details about it. The good thing is that we in our team now, there is another student that is following up on this work again to see maybe which other things that could be looked at. For example, we are thinking about, okay, what nature-based solutions could be locally made possible for us to be able to treat the salty water, because right now the techniques available are quite expensive, but right now we are trying to explore some nature-based solutions in trying to address this issue. So one student is currently looking at that. There are other works too that we have also done, such as the delineation of flat risk terrains, which is very important for our country. And one of my PhDs, who is also online today, has been working on that. Then we have also been looking at the connections between water, environment, and health nexus. So there is also a paper on that, and there is also some work we have done on climate change, which from Cote d'Ivoire, which you can also. So these are also some relevant papers that you could look at. But right now, I just want to talk about one simple example, which has also been published by one of my PhD students, which is climate change impacts on Greater Accra region under the SSPs. Now, when the motivation for this work was that when you take a lot of different models and you look at the assessment reports for Africa, different models always give different results for the case of Africa. So we felt that there was a need for us, especially the SSPs that are very new, for us to look at the Greater Accra region. This is the capital of our country. This is where you have a lot of people in this place. And this is also where we think that climate change, in one way or the other, can contribute to high electricity tariffs and all the other things that goes with it. So in this study, we try to use the SIM6 simulation models to explore the impacts of future precipitation and temperature over the Greater Accra region in the context of the energy and food supply. So this is showing the, the Greater Accra region. Now, there is something I want to emphasize here. In this big region, we had just two meteorological stations. No, I think there are three meteorological stations. We have Pokwasi, Accra, and Tema. So, and these were already skewed to just one location. So we had to develop a way by developing virtual stations, and at least during that time it was not that straightforward. But now it is very easy that if you want to have virtual stations, you could easily use the NASA power possibilities in order to get more data sources. So this helped us to be able to have a good for coverage for the whole study area. So we look at the SSP1 and then SSP2, then SSP7, and no SSP3 and SSP5. So looking at the different interventions, business as usual, or considering the worst scenario or the improved scenario. Now, so we use the data from the Princeton University Global Meteorological Forcing Reanalysis data set was used to construct for the virtual stations, but just as I mentioned now, it is also possible to do that through the NASA power. So we have to verify that this data is good enough, and the verification showed that this was really good enough because the R squared values were really high, which shows that the data was good to go. Then we try to use 6 regional climate models. It is possible to use the 36 plus of these models But after a bit of analysis and work in our region, these six appear to be much better. Now we try to use the six because at the end of the day, it is each of the models is giving some biases. So at the end, we made an ensemble mean that helps us to have a better understanding of the performance of the models. So if you look at the results for mean precipitation changes between 2021 and 2059, it shows that in some areas the increase is going to be high, and in some areas it's going to be less. In fact, those from Ghana, already we are experiencing some of these extremes. And recently this year we had huge flooding in Accra, which caused quite a lot of mess for the county. So we are already experiencing quite a lot of these challenges. The other one was the temperature max for the same period. And you could also see that for the temperature max, this is also very variable across. The reason why in this particular work we also look at temperature is that, we are in the tropics, and generally the weather is always very, very hot, which means if you stay in your house, you have to use a lot of air conditioning. So, understanding the temperature behavior is very critical for us to understanding our energy needs or our energy demand. And also, the Ghana government have also launched an energy strategy for the next several decades. So this work was to help us to understand how the future climate scenario, especially when it comes to the temperature maximum, and will inform the integration of renewable energy such as solar panels, and because we have quite a lot of sun. This is also looking at the temperature mean, which also shows that is quite a variable across the different regions. In fact, you will see that where you have the temperature minimum with high potential to increase, these are areas that are very densely populated, with quite a lot of what I call small scale industries springing up in these areas, which means that these results, if we go further, the issue of what we call urban heat islands is something that is propping up in these areas, and is something that we are currently understudying to see if we can get some more details findings. So in all of this, precipitation and temperature, precipitation will continuously is a challenge, is bound to decrease. But we also see that when you go through city to city, town to town, this is also a variable. For some cities, it's increasing. For some cities, it is decreasing. So it is something that is very difficult. For a temperature maximum and minimum, there is in general an increase across board. So these are some things that at least we have found in this kind of work. For the sake of time, I will just briefly also introduce some infrastructure that we have with other partners, which we think it could also serve as a way for our future collaboration in other matters. Is about carbon sequestration, where the University of Energy with other partners from Europe and across local partners have jointly come together, because for us to be able to do climate change studies, it is also important we understand our carbon cycle. And so we try to adopt the eddy covariance technique, and this presentation is by one of our staff, um, Mr. No, Dr. Caleb Mensah, who is championing this with some other staff on this particular one. Now, what we are trying to do is that in our forests, generally, we don't really have a lot. In fact, we don't have measurements for some of these things for us to understand how our rainforest is also sequestrating the carbon and what have you. So we try to install a tower that has a capability for using the eddy covariance techniques. And this tower currently is located in where we call the Beer Tunnel Forest Reserve. Um, okay, this map has some grid. So if you Google the Beer Tunnel Forest Reserve, you are going to see where it is, and you could maybe trace to see which parts of which latitude is crossing your country, to see for us to see whether we can do some kind of a collaborative research if you have also similar stations in your country. So these are some photos showcasing the entrance to where this tower has been placed, and this is a picture of some of the collaborators that are currently working with our university, and this is our vice chancellor in the middle, Professor Elvis Asarabediako, presenting some collaboration work with another university. So this tower is about 60 meters. So roughly, so you can see that the instrument is such that is several heights above the crown of our trees. Our trees are very, these trees in this particular forest, I think most of them are above 40 meters. So we try to give some allowance for us to be able to have a very good footprint. So this is the installation process that we've done, and these are some more photos from this forest. So I would like to end there by saying that this is more like what I call introduction to our collaboration, introduction to how we can join hands in co-sharing, in co-supervision, in co-joint research, whatever we call it, so that we can be able to see how South-South collaboration can be enhanced, can be sustained, so that by our co-sharing and co-dialoguing, we may find some good solutions in addressing our respective country needs. So on that note, thank you everyone, and over to you, team from the Institute, to take over. Thank you.